The world around us is built out of atoms, the universe's tiny building blocks. And chemists have learned to understand and communicate how they go together using a kind of code. It's a language that doesn't change between countries and has been developed over the last 300 years. It is written and understood by scientists across the world. Written in symbols, this is an elegant and precise means of communication. We call it a chemical formulae, and today we're going to unlock this secret language. Chemical formulae are perhaps the single most important idea to get your heads around if you want to start doing chemistry. They are a sort of chemical shorthand that allows chemists to quickly and accurately communicate exactly which atoms or ions are present in a substance. Take this for example, CaCO3. That's the formula for calcium carbonate, found in chalk, limestone and marble. Formulae like these are common in GCSE Chemistry courses. Chemists must be able to look at that formula and then work out which elements are present and how many of each type of atom are listed in that formula. The first thing to note is that we use chemical symbols, not their names, and this has a big advantage, not only because it is quicker and easier to write down, but it allows chemists from around the world to communicate with each other in a common language. See, every element has a 1 or 2 letter symbol associated with it, and that stays the same in every country of the world. Copper is the English name for this element, but it's known as cuivre in French, cobre in Spanish, and Kupfer in German. Please do not judge my pronunciation. However, as a chemist, all of us will use the same thing. We will all say Cu. That comes from the Latin word cuprum, actually, but it means we've got a common language for our scientific communication. Now, let's look at those symbols in a bit more detail. Remember that there are only 118 elements which we've discovered so far, and they're all listed in the periodic table. If we have a look at the periodic table, we'll see that the elements' symbols take pride of place, and as this is an English version of the table, we notice that the element's name has been listed in English underneath. Look at those symbols carefully. You will see that a few of them have a single capital letter to represent the element. For example, carbon C, oxygen O, nitrogen N. However, most use 2 letters. In this case, the first is capitalized and the second is lowercase. That is important. Writing Cu like this or this is not only incorrect, but you could confuse chemists and you'd certainly lose marks in the exam. By the way, in all UK science examinations, you'll be given a copy of the periodic table if you need it, and so there's no need to remember the symbols. You can always look them up. Having said that, you're probably going to use them so often that the first few are going to become second nature to you anyway. So, let's have a look at that chemical formula again. CaCO3. Step 1. Let's count the capital letters. That's going to tell us how many different elements there are in this formula. We've got 3, so there are 3 different elements in my compound. Step 2. Identify them. So, Ca. Remember that lowercase a tells us this is a 2-letter symbol, so I'm going to look up Ca in the periodic table and discover that it's calcium. Next, we have the capital C and the capital O separately, which when I check in the periodic table, I see that I've got carbon and oxygen present in my compound. Step 3. Let's look at that small number 3. It's called a subscript. And the little 3 after the O tells us that there are 3 oxygen atoms in this formula. Please note that the small numbers always refer to the element in front of them in the formula. So, this formula means 1 calcium, 1 carbon, and 3 oxygens. Just notice that we don't put a number 1 next to elements with just 1 atom present. Chemists never write more than they have to. Technically, this formula is telling us the ratio of the elements in the compound, and that will become important later when we start looking at formula masses and reacting mass calculations. For now, let's get some practice in. Here's a classic. H2O. That's 2 elements, hydrogen and oxygen, with that number 2 being linked to the symbol in front of it in the formula, so that's 2 hydrogens and 1 oxygen. And a more complicated one? Alright, here's sodium carbonate, Na2CO3. Look carefully, 3 capital letters, 3 elements. Sodium, carbon and oxygen, in a ratio of 2 sodiums, 1 carbon and 3 oxygens. I'm now going to put up 3 more on the screen, and I'll leave them there for about 10 seconds to give you time to work these out for yourself. But you may wish to pause the video now before I give the answers. Well, if you got those correct, then frankly, you've got the basics. If you need more practice, I've linked a worksheet below that will help you. If you want help or advice, just leave a comment below and I'll help you out. Sometimes things get just a little bit trickier, and you might come across a formula that looks like this one. Now, that little number 2 at the bottom refers to everything that's inside the bracket. So, although we've only got 1 calcium, we've actually got 2 oxygens and 2 hydrogens. Let's look at this final one together. It looks complicated, but we'll take it apart bit by bit. That CO is a 2-letter symbol and represents cobalt. There's 1 of them in this compound's ratio. N is nitrogen, and although there's no number right next to it, it is inside the bracket, so we need to multiply it up. 1 times 2 is 2, so there we go, there's 2 nitrogens. Finally, that O is oxygen. There's a little number 3 next to it, so we might think that there's 3 oxygens, but remember, it's inside the bracket as well. So we've got to multiply it by 2, and that gives us a total of 6 oxygens in the formula. And I've got to be honest, that's pretty much as hard as it can get. If you want more practice of these, they are on the worksheet, which again is free there for you to download. And if you've got questions, you can ask them here in the comments, and I promise to answer in there and get back to you with an explanation. Oh, by the way, cobalt's symbol really shows us the importance of that lowercase and capital letter combination. CO is a single element, cobalt, but CO is a carbon and an oxygen together, giving us carbon monoxide. That's 2 very different substances. Once you can read formulae, a new world opens up. You'll begin to see the patterns in chemical reactions in nature, industry, and in life itself. Every reaction, every calculation you do in chemistry from this point onwards will depend upon these foundations, so do take time to practice them. If you need more help, remember the sheet's there for you to download, and you can ask your questions below in the comment section and I will get to you with some help. Next time, we're going to take one step further and we're going to use these formulae to calculate formula mass, and then we're going to start balancing chemical equations. Until then, keep exploring, because chemistry is the story of matter. And formulae, well, they're the alphabet we use to write it down. Have fun until next time. See you later.